Hello, this is Mike at GameFromScratch, and welcome back to our ongoing game development for complete beginners tutorial series. Today we are going to be looking at dealing with sprites or images in Love 2D. Now there's some terminology we need to cover here, and in Love, an image and a sprite are pretty much the same thing, but in other game engines there's a couple different terms you should probably be aware of. Traditionally, an image refers to either an image stored in file or in memory, your traditional or in computer system memory, and those are traditionally your files such as your bitmap, PNG, GIF or GIF if you want to say it the new/old way. Your traditional image files, those are normally an image. Now, when they're in system memory, they also can be referred to as an image. Now, next up, there's something called a texture. Now, a texture is pretty much the same thing, but it's in computers, the GPU's memory is where you would traditionally go from being an image to becoming a texture, is when it's loaded into the GPU. And traditionally, textures are used in 3D when they're pasted on some geometry, such as, think of a map of the world. It's got a sphere as the underlying shape, and then there is the texture, which is the picture of the world itself. Works the exact same way in 3D. Well, in 2D graphics, you're actually faking 3D. So your sprites, another term I'm about to cover, your images, etc., all need to be drawn on something. And essentially that means they're a texture drawn on a quad. So think about it as an image represents the image on disk or loaded into system memory. A texture is generally that image on the graphics card in the GPU, and then it's applied to some geometry such as a quad, which is just, a four-sided polygon to make it look flat like any other sprite in the world. Now, sprite is one final term, and basically it just refers to an image or a texture, whichever one you want to call it, that moves. And the term sprite comes from the early 80s. Texas Instruments was creating chipsets, graphical chipsets, and one of the major killer features back then was an image that could move. So if you think in terms of, say, Mario, the background is not a sprite, but Mario himself, the score, stars in the world, etc., those would be sprites. And early hardware had acceleration for sprites. So say the Commodore 64 might have had blitting support or drawing support for up to 8 or 16 sprites. Now we've moved way beyond that kind of hardware, and everything now is accelerated 3D graphic stuff, so 2D is faked now, but the terminology has stuck. So you might see sprite used in place of image or in place of texture, but basically that just means that it is something that's drawn, a 2D graphic that's drawn, and that it moves. There's not really a big difference between any of those things. And I mostly tell you all this just so you have the terminology down if you switch game engines. So without further ado, let's jump on in. Now, first things first, we're going to have to go ahead and actually get a sprite. And I've grabbed a couple. I'll throw them on my desktop. And I'm using this sprite right here, which is fictional jet plane. And I'm using this sequence of sprites. We'll get back to that in a second. Now, in order to make these, I actually got these for free from the web. You can grab them from GameDev.net. I'll link this from GameFromScratch. Where did you go? Anyways, never mind. I will link the actual asset pack on GameFromScratch later on, but it's a collection of sprites you can see. Oops, that's not it. Where did you go? Aircraft sprites. It's a zip file, includes a number of different views and different graphics in the background. Now, I've gone ahead and I've removed the transparency on the background, and if you need help figuring out how to do that, I actually just put a video up on GameFromScratch that shows how I actually created the sprites we're going to go ahead and use. But once again, the graphics we're going to use are this guy for our first example, and this guy for our second. Now, the first one, let's jump right in. So we need this alc17.png file. Let's go ahead and grab that, and then we'll copy that into our projects folder. So right there. So it's right alongside my main.lo. It could be in a subfolder, whatever. It doesn't really matter where you put it, as long as you have access to it and you get the path right in your code. So now that that file is available, we're just going to go ahead and load it. So first off, we'll call it image file, and we're going to use that variable in a second. So love.loads, remember this is the function that's called when your code starts up. And we just go ahead and create that image file. So love.graphics.new image, and all you do is pass in the file name. Now, once again, so all of the image files I'm using in this example, I will link to a GameFromScratch page. I will also make all of this code example there as well for you. So if you're not keeping up with here, don't worry. There's a link you can grab the sprites and the code that you require to do all this from GameFromScratch. All right, so that loads the graphic into memory. So that's into system memory at this point. So now let's go ahead and draw it. And this is quite simple. Again, in our draw call. And then what we just call is love.graphics.draw, and we pass in the drawable, which is our image, so image file. And go ahead and run that, and ta-da, there is our sprite drawn. Again, remember, everything is drawn relative to its top left, and in this case, in the top left corner. Okay, so that is that. Now, next up, what we're going to deal with is that second sprite sheet. Let me just go ahead and grab that. So it's this guy right here. And this is going to be a bit more complicated. Now, this is a very common way of doing things. This represents, oops, can I zoom? Yeah, here we go. This is, there's a number of different terms for it when you put a number of sprites together in the same graphic file. It's either referred to as a texture atlas or a sprite sheet. Very common terms, very common thing to do. Now, the reality is one of those things when you're dealing with a whole bunch of graphic calls, loading a bunch of separate files is actually rather intensive. It takes a lot for your GPU to do it. So if you want to make things run as fast as possible, you want to keep as many images in memory as is reasonably possible, especially if they're going to be drawn frequently. And a common way to do this is to lump them all together in a sprite sheet. Now, it's very common for hardware to require these sprite sheets to be a power of 2. So that means width or height, you want them to be, say, 256 by 256, 512 by 256, 1024 by 1024, 2048 by 1024, 4096 by 2048, etc. Now, I do want to warn you, once you get up past 2048 by 2048 in size, you can start to have some incompatibilities. Now, it's mostly just old crappy video cards. I know for a fact the Intel integrated HD 3000, which is about a 6-year-old Intel integrated card, is about where you stop having support for 4K textures or 4096 by 4096. So if you want to support absolutely ancient machines, keep it under 2048 by 2048. If you're working on modern hardware, 4096 by 4096 is pretty safe, and even 8192 by 8192 is pretty safe, but there's a lot of times there's no means to go up that big in size. So anyways, this is a very simple file. This particular one is 256 by 256. And what that turns into is 1, 2, 3, 4, 5, 6 images all packed together. So this is 128 by 64, 128 by 64, 128 by 64, 128 by 64, etc. I'm only going to actually use the top 4 of them in this particular code just because I'm being lazy. But let's look at actually how you deal with that. A very common thing, especially when you're doing animations, is to have multiple frames of animation. And we're going to use a very similar chunk of code to start, but now we're going to need a couple more things. First off, let's create an empty table to hold all of our frames of animation. So just like that. And we're also going to want to have an active frame. So this is our current frame of animation, the one to draw right now. And we also want a number. So this is the current frame in the sequence, like so. So now in our load, after we load, oh, and that's actually a different file. All right, so we've loaded our new graphic like so. Now what we want to do is grab each particular frame. So like I said, I'm only going to grab 4 of the frames. So let's do this. So frames. So we're using our table like an array. That is, we're indexing it with an integer in order, 1, 2, 3, 4, etc. So frames at 1 equals, and then love.graphics.new quad. Now, a quad is, remember when I told you earlier that a texture can be applied to a physical shape? Well, a quad is just a rectangle. It's think of it like a viewport within the image. So if we wanted to just use a subsection of this image, we only want to grab this chunk here, for example. We just need to define a quad, or the 4 sides, the top left corner, the width and the height of our shape to grab for that little subview. And we're going to create one for All right, what are you doing? Come on. All right, so we want this guy, this guy, this guy, and this guy. So to do that, create a new quad, and then you're just passing in the dimensions. So 0 and 0 is the top right corner, and it's 128 wide, 64 high. And then we need to tell it how big our source image is. And for that, we just call image file. So the image file we just created right here, well, it has a function attached called get dimensions, like so. Okay, let me just scroll that down slightly so you can all see it at once. All right. So we just did that to define, so we're just basically saying a rectangle from the very top left corner, 128 over and 64 down. So we're saying copy from here to over 128 and down 64. So we're saying grab this space right here. So we're defining that as our first quad. Now we're going to do a little bit of cut and paste coding. So now we want the next one over, 2, 3, and 4. So 2 is going to be over 128, but otherwise the same. And then this next one is at farthest left, but down 64. And then finally over 128 and down 64. So all we're really doing is changing the left top point of the quad each time, because the width and the height are going to be the same for every frame. So now we have all 4 of our frames defined. So basically we just defined a rectangle here, then a rectangle here, then a rectangle here, and a rectangle here. All right? Now, active frame is what we're actually going to draw. And we'll go ahead and define that one as active frame equals frames at current frame. So current frame is currently 1, so active frame will point at this guy to start. All right, so now we need to do a little bit more special stuff in our love draw call. So right here we are drawing the image file. But now we need to just pass in, so it's the same thing, we're still drawing that image file, but we're also going to pass in active frame. So this is telling it, use this image file, but only draw this portion of it, or this little rectangle within. And that, in theory, why are you up? That, in theory, should run and just give us the top left corner. Perfect. That's exactly what we want. So now let's flip between the frames. And this is going to require a little bit more code. So close that guy down. So now we need to implement our update call. Remember, update is called every frame is passed dt, which is the delta, or the amount of time since this was last called. And we're actually going to use that value this time. So what we actually want to do, we want to create a function called elapsed time. So sorry, a variable named elapsed time. I think I said function there. This is just going to be a counter. So we're only going to update every second. The delta is the amount of time that lasts since the last frame. So we're just going to keep accumulating them until a second has gone by. So that's just a matter of just going elapsed time equals elapsed, I can't spell today, plus delta. Okay, so delta will be a value such as 0.01, the amount of time since the last time update was called. And we'll just keep it as a running total. That's all we're going to do. And then finally we'll go if elapsed, still can't spell, elapsed time is greater than 1. So if 1 second has gone by, then, and we'll end that off. All right. If 1 second has gone by, and then we just want to loop through all of our frames. So first let's check to see that we haven't already gone past them all. Current frame is less than 4. Then current, I think I have the wrong value there, equals current frame plus 1. This is what happens when you switch between programming languages that use, hey, what are you doing? All right. All right, so that's our if condition. If we're less than the 4th frame, I think I actually need to change that to 5. I hate not using a 0-based language. Otherwise, go back to the very first frame. So we're basically just saying, as we go through each of our frames, if we've updated our frames past the number of frames of animation we've got, so we're only going to use the 4, remember. So if we're going 1, 2, 3, 4, so if we're less than that, then go back to the first one again. Okay. And that should be the end of our if, like so. And so now that we've updated that, all we're going to do is tell it, all right, the frame that we are using now is our current frame that we just updated. So this is going to every second jump through to the next frame of animation, and it will make the value that we are going to draw right here change. So we're just kind of changing rectangles within the source to give us the illusion of animation. We're going to do it once every second. And now that we've done an update, it means a second has gone by. So let's start our counter over again. So now we're going to go ahead and run this code, and as you'll see, every second, it's going to the next animation frame. So first frame, second frame, third frame, fourth frame, back to the beginning, second frame, third frame, fourth frame, back to the beginning. Now, you could have done it with all 6 frames. I just being lazy, don't want to, all you would have to do basically is another 2 lines here and you're off to the races. Change this up to a 6th instead, and you're good to go. But I'm going to just go with the 4 frames of animation. So hopefully that all made sense. Now we're going to look a little bit more at drawing. So far we've just drawn it by the default, and that's at the top left corner of our screen. Let's look at some of the options we can do here. Now first, next go love.graphics.draw image file active frame. Now the very first thing we can do is pass in a new coordinate. So this will draw it down and over 100 pixels. So we're specifying the x coordinate here and the y coordinate here to draw its top left corner. Now a very common thing to do is to center it to the screen. And the easiest way to do this is to actually go, so we'll change these values. Instead of doing 0 and 0, we can just do love.graphics.getWidth divided by 2 and love.graphics.getHeight divided by 2, like so. And go ahead and run that, and it will be almost centered. Now you notice it's off by a bit. Well, that's because it's not taking into account that the width and the height of our actual image. So if we wanted this guy to be properly centered, we actually need to take half of its height and half of its width off of the amount that we're doing here. Or we can change the pivot amount, and I'll explain that in a moment. Now first, let's actually do it by calculating half the width and half the height. First, we can cheat. We actually know that it is 128 wide, so we can do half of that. And there's the height. So we know it's 128 by 64, so half of that is 64 and 32. So if we just subtract those out, go ahead and run it, we see we are now nicely centered. Perfect. However, that's probably not going to always work if your values change in size. So sometimes you're actually going to have to calculate them. And this is not an intuitive thing to do, or not as intuitive as you'd think it would be. Now, next up, we're going to go ahead and calculate based off of the current frame of animation. And this code is going to look a little ugly. Now, if we go back to Quad, so here's the documentation for Quad. Let me just zoom this up for you. You'll notice Quad has this value called getViewport, and this actually gets the rectangle of the viewport. So we'll see it come up here. It's a Quad getViewport, and it gives the location, the X and Y location, and the width and the height. So what we want to do is get the width and the height value from here. But you notice how it's got multiple return values in a single function. This is one of those oddities of Lua. Most other programming languages only allow one return type for a function. So what you would normally have is getViewport would return a rectangle object, or you would do a getWidth, getHeight, getX, and getY as 4 different functions. But what Lua could do is pack them all into one particular value. So how do we go about getting just this third value here in the return type? Well, we can do that this way. So instead of minus 64, so we're going to check it instead. We can do that with select 3 active frame colon get viewport, like so, divided by 2. And I think that's good. So I'll go ahead and run that, and the same end result. So what you're saying here when you call this function select is that you've got multiple returns. So you've got as you can see here, we've got 4 return values, and I'm just saying here, give me the third one. And we do the same thing for this other call as well. So instead of this minus 32, we could do that as select. So that'll be the 4th value, active frame, get viewport. I'm gonna have too many brackets here. All right, end of, there. So go ahead and run. Okay, I think I got too many. Go ahead and run that, and it is done for height. So that is one way you can get this value. It's a little awkward, and the truth of the matter is you probably don't want to do this on a per frame basis anyways. You would do it up front here in the load column. Only calculate it once if you actually needed it, instead of doing this over and over and over again. But if you have multiple return values and you need to get one based off its position, so you need like the 2nd or the 3rd, you can grab it this way. Now, if you don't like this syntax, there's actually another way of going about doing this. And what you do is basically treat this return value. So what this function right here, this active frame gets viewport, returns us back 4 values. And what we could do is immediately say, all right, take those values and turn them into a table by doing that. And then once you've done that, you can access the 3rd entry in that table this way. Go ahead and run that, and oops, I think I just screwed things up. Oh, I didn't actually divide it by 2. And there you go. So multiple return values in Lua is a little screwy, and if you need to access a particular one, you can do it either way. You can either use this select function and say which one you want, or you can turn it into a table using these squiggly brackets and then access the actual value using the square brackets, just like you do for an array. Just like here when we said make the 1st value in this array, 2nd value, 3rd value, you can read them the same way. So we're saying get me the 3rd value, and this will have created a 4 value table. So either way works. It's a quirk of Lua. You won't find that in too many other languages. It's one of the very unique things. It's a powerful feature, but it's not immediately obvious how that works. So I think that's about all I intended to cover today. There are other topics such as Sprite batch, which is a way of putting a whole bunch of draw calls into a single one to perform them much faster, but we'll cover that at a later date. We covered quite a bit today, so if I lost you on anything, please let me know, and I will go into more detail in the comments below. And once again, I will give you a link to this code that is available on GameFromScratch, including the images we just used, and a link to the original images I grabbed. I will also put a link to that video I was talking about how I turned those images to make them transparent. And when I'm saying transparent, I guess I should give a moment of discussion that way. When you're dealing with different image formats, some support transparency, some do not. For example, GIF and PNG support transparency. That is, you can have a pixel that is see-through, and that results like this, where you see in our particular code, or in this case, you just get, you keep screwing up. You get this black background as opposed to whatever color was there. That way when we draw it, if we draw our image over top of another image where there shouldn't be any pixels, there are none. Well, you have other formats such as BMP or bitmap, and it doesn't support transparencies. And what you had to do back then was to use something called chroma keying, which is to say anything with this particular color, don't draw it. And it's a bit cruder way to do it. If you have no other reason not to, just use PNG and use transparencies. It will just keep your life simpler. And there's not a lot of reasons in this day and age with the amount of memory we have available to not just use PNG. The quality is pretty good. It supports transparencies. It supports 8-bit color. You should be good to go. So that's about that. That's all I wanted to cover. Again, if you have any questions, let me know in the comments down below. See you later. Actually realized there's one other thing I wanted to cover here. Sorry about bringing you back like that a little bit jarringly, but I forgot to show you how to draw things better positioned. Now we've been using this love.draw, and you'll notice we added a couple more dimensions here. For example, we added the ability, we started off with just this line right here, which is to say, we just want to draw this image. Then we just want to draw this image, this rectangle within that image. And then we added on top of that at this position where we did the width and the height here. We can actually do a lot more. So let me just change this out a little bit. So instead of doing these 2 lines of code are a little confusing to read. So I'll just come back here and go 0 and 0. So now we're back to drawing at the top left corner of our screen. As soon as I fix my error, which is missing comma here, all right. So this will draw our image, our rectangle within the image here at the top corner of the screen. Now there's a lot of stuff we can also do here that's pretty powerful. So on top of that, we've got additional functions, and I will show you in the help. So drawable will take, so here's the drawable. We can also pass in, as you saw, the quad to take as a position, but we can also pass in the X and Y, which is the location to draw it, but also a rotation and scale. And then there's other things here, we'll get to those in a minute. So the big one is, so here's the position. So next up we could also do, the next value here is the rotation. So we can come in here and also pass in a rotation value. Now rotations are in something called radians. And a radian is kind of thinking in terms of fractions of a circle. I'm not going to get into the mathematics behind here, but if you want to work in degrees, it's easy enough. So just use the function math.rad, and this will convert radians to degrees, or degrees to radians, sorry. So we're going to rotate by 90 degrees. Go ahead and run this code, and you will now see nothing. This shouldn't matter, but just check what's going on here. All right, so it must have been off screen. All right, here, let's move that guy in a little bit more. So move in 200, move down 200, and here you see our image is now rotated 90 degrees from where it started. So we can go back here and turn this back into 0. Hopefully that code is not going to piss it off. So you see it there, 90, like so, 180, like so, etc. So if you want to rotate your drawing, you can just do it as another parameter as shown right here. Or we can, of course, leave that alone. And now next up is scale. So what we can do is scale, this is by a factor of. So if we want to make this twice as big, so twice as wide, twice as high, we can pass those two in as well. So there you go. Now you see we're twice as big as we were. And we can also do, say, 4 times as big, like so. Pretty cool. Now the last thing we can do here is set the origin. And origin requires a little bit of explanation. I was actually using it before when I was calculating the by taking the viewport and getting half of the width. Well, we could also have done that by using the origin. Now when I say origin, this is where the sprite is drawn or translated relative to. And so far it's drawn relative to its top left corner. So we know this guy is 128 by 64 in size. So if we wanted to draw it relative to its center point, we could also pass in the values. So 128 is its width, so we want half of that, or 64 half of that, which is also known as 64 and 32. And now all of the drawing and the translations and scaling will be done relative to the midpoint of our object. Now the fact that we're scaling it 4 times up is going to make this result seem a little bit weird, so let's just get back to normal size scaling. And you will now see, instead of being drawn here towards its relative, so we're saying 200 pixels in, 200 pixels over. This is 200 pixels in, 200 pixels over to the center of our sprite now, because we're telling it that it's drawing relative to this location within that shape. So that's about it. There's one other value in there for shearing. It's not something you're ever going to use. We're not going to really cover on that one. That's for like tilting your image. Very, very rarely used in games. So sorry I missed that on the first edit. Hopefully I can edit this in so it isn't so jarring. But that's it for drawing. That's all I want to cover today. Honest for sure, we're completely done. See you next tutorial.